Hello, and welcome to the Current Science and Technology podcast from the Museum of Science in Boston. I'm your host, Susan Heilman, and every week we bring you interviews with guest researchers and our museum staff covering science and technology in depth. I have with me Dr. Daniel Heller, a chemist from MIT, and he'll be talking to us about glowing carbon nanotubes and what exactly that means. Hello, Dr. Heller.
Hi.
So, glowing carbon nanotubes. We've talked a lot in this podcast about carbon nanotubes, but if you want to give us your 10-second spiel of what a carbon nanotube is.
Okay, well, a carbon nanotube is a cylinder made of graphene, which is basically one single sheet of graphite, which is the same stuff that's in pencils.
Okay, so we're talking about a very, very small material, very thin material made entirely of carbon.
Yep, exactly. It's about 1 nanometer in diameter, which is about 1/50,000th the size of a human hair.
Okay, so very, very small. We've also learned that carbon nanotubes are very, very strong, and they have a number of interesting properties, and it's one of those other interesting properties that you are exploiting in order to do your research.
Exactly. So some carbon nanotubes can give off light when light is shined at them, and that's called fluorescence. And fluorescence is the same thing that you see when you look at a UV light, a black light, looking at your shirt or something that glows, and carbon nanotubes do a very similar thing.
So what do you then do with these glowing carbon nanotubes? As cool as they look, what can you use them for?
So their fluorescence is very interesting because it doesn't bleach, it doesn't decrease over time like most molecules do. And you can use this to make a sensor because the intensity, how bright it is, can be tuned when a molecule that you want to measure hits it. And so you can detect molecules that will hit the carbon nanotube.
Okay, and an example of a molecule.
So right now we have made sensors that can detect glucose. For diabetes, if you want to measure blood glucose, we're trying to make a sensor that can measure the amount of glucose in the blood, and you just have to shine light at the carbon nanotubes, and they give off their own light, and that light would tell you how much glucose is in your blood.
So the brighter it is, the more glucose?
Exactly. Or we can make it work the other way. The darker it is, the more glucose.
Sure.
Or there's one other thing. The color that it changes into would tell you the amount of glucose. The light can shift in wavelength and shift to redder or bluer, and that would tell you the amount of glucose.
So let's imagine for a minute, in a diabetes patient, where exactly would the carbon nanotubes be just free floating in the bloodstream, or would you remove the blood and then check it?
No, in this case, we'd probably want to keep the carbon nanotubes in one place so we knew where to shoot a laser at you. So we could put the carbon nanotubes into a little capsule and put that under the skin, for instance, and shoot a laser at the skin and that part would give off light, and we can use that light to tell you how much glucose is in your blood.
Interesting. So instead of doing a finger prick, you could almost have like a home laser kit.
Exactly.
Someone could shine onto their skin and find out what their glucose level is.
Exactly. At MIT, a few months ago, they mentioned a glucose tattoo, or a glucose sensor tattoo, a tattoo on your skin that can tell you how much glucose there is by just shining light on the tattoo.
And how far away is something like that from working? Have you been able to do it in humans or mice or anything?
We've made sensors that work in mice. They weren't really detecting glucose at the time, but people in my lab have been moving in that direction recently.
Okay, and what else does the future of glowing carbon nanotubes hold besides diabetes detection?
Yeah, we think that we can detect almost anything if we just put the right stuff on the carbon nanotube. So all these carbon nanotubes aren't kind of raw, naked carbon nanotubes. They actually are clothed with something. And so what I did was put DNA around carbon nanotubes and use the DNA to detect things that like to damage DNA. And those things are, for instance, oxidants, the things that you would take antioxidant foods, for instance, and try to reduce in your body. And so I was able to work to detect those oxidants in the body.
What are some of those oxidants? I mean, people know antioxidants. We think of things
green
in
tea
fruits
and
blueberries.
Blueberries,
Yeah.
exactly.
Yeah.
But oxidants are things like hydroxyl radicals, certain radicals in the body, or excited oxygen called singlet oxygen, or even hydrogen peroxide, which you probably have heard of. You put on cuts. Well, your body can make hydrogen peroxide, and that could somehow damage your DNA. And the DNA that we wrap around carbon nanotubes can actually be used to detect those oxidants.
Is it as the DNA wrapped around the carbon nanotubes, does that become degraded, which then
Exactly.
affects the fluorescence of the nanotube?
Exactly. With some of these species, that's true. Not hydrogen peroxide, but which the nanotube can actually detect directly. But these other radical species can damage the DNA in a certain way and make a certain type of chemical adduct, we call it, a damaged piece of DNA that the nanotube can detect. And the interesting thing is that the nanotube detects one kind of damaged DNA damaged by a certain oxidant differently than another kind that's damaged by a different oxidant.
So would it fluoresce differently?
So yeah, it will change color differently, a different amount, or we have that one type of oxidant that will quench the fluorescence, make it decrease, and another type that will make it shift.
So how would you imagine using the carbon nanotubes in a person's body then to detect this? Is something else you place in a capsule under the skin and then detect, levels of oxidants in a person?
Well, it turns out that the oxidants are really interesting to detect mostly for research at the moment, where carbon nanotubes can be used as a tool to learn about cancer and learn about how these oxidants play a role in cancer. We know they play a role in cancer because a lot of types of DNA damage result in cancer, but we don't know exactly what the real role is in causing cancer. And so there's a lot of work to do where we can use a sensor that can detect these types of oxidants and detect how they're different from each other. And we can learn about them by maybe putting the nanotubes into cells and putting the nanotubes into mice and making a detector for those oxidants without actually putting them to people. The people come in where we want to detect, say, if we have a type of cancer that is okay for a while, like prostate cancer is actually okay in the body for a while. Like you can have that cancer and you might never actually die of that cancer. But some types of prostate cancer might actually turn into another kind of prostate cancer, which is very dangerous. And so we're thinking about using carbon nanotubes to detect the molecules that come from those cancers that are dangerous. And so maybe we would implant a little particle under your skin, and it would sit there, and we'd wait until it detects the molecules that tell you that you have dangerous cancer, for instance.
Okay, so it could tell once someone knew they had prostate cancer.
Right.
Then
You can put it under their skin. Then you wouldn't put it under everybody's skin, and then
Right.
wait until that prostate cancer became dangerous, and then it would, tell you something.
Interesting.
So that's one way.
And again, it would just work by, you shine a shine a light at it, and however it does or doesn't fluoresce would
Exactly.
give you that information.
Exactly. So you wouldn't feel that laser. The laser's just light. It wouldn't have to be very powerful laser. It could be like like the laser that's in a CD player or a laser pointer, and it's just shooting the light at the skin. And the interesting thing about the carbon nanotube is that the light that the carbon nanotube gives off will also go through the skin.
Ah, yeah, that's what I was going to ask, is how do you put it, if it's under the skin, how do you see if it's glowing or not? But you can see it through the skin. That's also
Exactly.
really pretty cool then.
Exactly. There are certain types of light in the range of about 800 to 1400 nanometers where light can go through skin. So basically we call that the near infrared light that's a little bit redder than red, and we can't actually see with our eyes, but it can go through skin, and we can detect it in our detectors that are attached to microscopes or whatever we want, or even in a little watch or something like that.
Cool. So you named a lot of different things, and you're probably working on a lot of different things, but what specifically are you doing in lab, when you go in tomorrow? Which of these projects are you working on?
Go in tomorrow? That's a long time from now. I'm going in right now.
Okay.
So actually, I'm working on the prostate cancer idea, because that would be something that could benefit people soon if we can get carbon nanotubes to a place where we have a sensor that will detect biomarkers for prostate cancer. Also, I'm working on various ways to detect all the types of molecules that would be interesting for all of biology. There's lots of things we want to learn. There's so much we don't know in biology about cancer, for instance, or other diseases, where if we could detect these certain molecules in a cell or in the body, and they were done by carbon nanotubes, which don't stop glowing, they don't bleach, and they could go through the bodies, the skin, would be really interesting, because we have lots of interesting tools in our tool chest, but we don't have all of them. And there's certainly things we would like to learn from carbon nanotube that can detect really lots of things that doesn't stop glowing and can do it in a cell or do it in the body.
Cool. So you really are working on some big general projects
Exactly.
even that can
Exactly.
have lots of different applications. Thank you, Dr. Heller, for joining me here today.
Well, thank you very much.
have with me Dr. Gary Harris, an electrical engineer who is normally a teacher at Howard University, but right now he's visiting at the Harvard Nanoscale facility, doing research there and teaching at Harvard. And the end of February is National Engineering Week, and so putting all of these things together, we've had Dr. Harris here in order to talk a little bit about his engineering research. Hello, Dr. Harris.
How are you? And I'm excited about the opportunity to say a few words about some of the things that we're doing. It's always fun to come to the Science Museum and get a chance to see the latest exhibits and interact with all the wonderful visitors that you have here.
So first off, all I really know about your research is that it's nano-related and you're an engineer. So what kind of stuff are you doing at Harvard right now?
Well, in general, I've been involved in the whole area of nanotechnology since the early 90s. And we've had at Howard the Howard Nanoscale Science and Engineering Facility for over 10 years now. And we were part of the original National Nanotechnology Users Network, which was a consortium of schools. And now it's called the National Nanotechnology Infrastructure Network, of which Harvard is a member, Howard is a member, Cornell, and 11 schools across the country.
Great. So have you collaborated with Harvard on your projects before, and what is it you're doing?
We've collaborated on a lot of different things, primarily things related to science education and nano education. This is the first time that I've had an opportunity to do a lot of collaboration in the area of the nanotechnology and working specifically with Bob Westerfield's group, who do some really fantastic things in the area of characterizing nanowires, and also getting an opportunity to try and grow a new material, for me at least, and that's diamonds, synthetic diamonds, and using those to make the next generation of electronic devices that do all kinds of things, from creating ultraviolet light that can be used to clean water to producing high temperature electronics.
Wow, and all with diamonds, but we already have diamonds. So is this because they're so expensive, or are you doing something different to the diamonds?
Well, these are synthetic diamonds. These are grown in the laboratory. These are grown under controlled conditions. And diamond, besides being the strongest material known to man, and most people know a lot about that, diamond is a semiconductor material, and it has applications for not only semiconductor or electronic applications, but photonic applications as well. Then photonics means devices that involve light. It's an exciting new material, and we know some things about it. We don't know a whole lot about it, and we don't know how to make it in very special ways.
And how do you go about making diamond? We know diamond is solid carbon. We've also talked a bit about things like carbon nanotubes here. And so how is diamond synthetically made?
Well, diamond is synthetically made by taking two gases and reacting them, hydrogen and methane. And under the right kinds of conditions, you precipitate out a material that can form as diamond. You use what's called a precursor, and these are little bitty diamond crystals that have been made by a number of different ways. The simplest thing to think about is just to take a diamond and grind it up, and sprinkle those crystals on your wafer, and then put your material in a high temperature microwave plasma, pass hydrogen and methane, get those gases to react and create a plasma, which is a cloud of electrons, free radicals, and so forth. And then they precipitate out, and you get diamond structures if you're lucky.
Wow, okay. And so that's something now that you're just trying here at Harvard?
That's something I'm trying here at Harvard, and some people have had some success with it, not a whole lot of success. It's a very difficult material to grow, but it has some interesting properties. And so we're trying to develop the technology at Harvard to grow it. And the group that I'm working with has been analyzing a lot of materials that we've grown at Howard University. You've heard of nanotubes, right? But most of those nanotubes are made out of carbon. We've been making them out of a lot of different materials like gallium nitride, silicon carbide, silicon germanium. These are semiconductor materials, and so they have some really exciting nano-like properties that people are just trying to exploit for the next generation of electronics, something that would take us beyond 2020.
Interesting. So, and your main goal for these synthetic diamonds is for the purpose of electronics?
Think of it in this way, that, the semiconductor field is like going to a restaurant and ordering lunch or dinner. And you have a lot of choices on the menu. And so, depending on your application and what you like to do with the material, you can mix and match materials to meet your particular needs.
Are you putting anything besides carbon into the diamond structures that you're making?
Eventually, we'll do what's called doping, adding impurities that help change the properties of the diamond using materials such as nitrogen and boron and other kinds of things. But right now, we're just trying to get our foot wet and trying to understand some of the basic ways in which you can grow the material and make it reproducible.
Right, that's one of the more important things. I also believe you'll be coming back to the museum in about a month. We have our Nano Days here, and I understand you'll be participating in some of that. You're going to be talking about your research at that?
Yeah, hopefully we'll get a chance to come back for Nano Days, and if that's possible, we'll bring our mobile lab called the Nano Express, which is a mobile scientific laboratory that gives people an opportunity, K through Gray, to get some real hands-on experience, to work with the same kinds of instruments that we work with in a laboratory in a mobile setting. And so it has over $700,000 worth of scientific equipment on it, and we take it all over, primarily up and down the East Coast. So if we get a chance, we'll really be excited about bringing it back.
So hopefully you'll be able to bring it back for Nano Days, and that's amazing to have that much equipment mobile that you guys can take around. So I appreciate you taking the time and talking to me about your research. I'm interested to hear more eventually on the synthetic diamonds and whether or not you're going to make nice big rocks.
Yeah, we're working on it.
Of those, to fund the other research, you make the big diamonds.
Yeah.
Well, great. Thank you for joining me here
All
today.
right. Well, thank you. And again, I want to thank everybody here at the museum for giving me an opportunity to say a few words. And it's always exciting when I get a chance to talk to both young and old minds about engineering, science, and technology. So thank you very much.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.